everyone. In this session, we are going to discuss about Power BJT. So that is Power Bipolar Junction Transistor. So what is Power BJT here? It's a three-terminal device. It has emitter, base, and collector. It is basically amplified version of BJTs. For example, what is power electronic devices here? It's one of the type of power electronic devices. So it controls high voltages and all. In normal BJT, it's a small signal BJT, normal BJT we are using. Here we are going to deal about power BJT. So the symbol here is normally as that of a BJT. So here this is the symbol. When it is NPN, your arrow mark will be away, and when it is your PNP, arrow mark towards the base. That is your emitter parameter defines whether it's PNP or NPN. Okay. So here now how the structure, right? So here we have vertical size structure. Normally the there is a difference in structure between a small signal BJT and the normal power BJT. The difference is here it is vertical oriented structure, because in order to have a it have to control high current and high voltage. So it is made up of vertical oriented one. And here we have layers, that is n plus, p, n minus, and n plus. So this n first, the layer which is connected to the layer which is connected to the emitter, it is n plus. N plus normally represents highly doped. Doping is nothing but adding of impurities. Okay. So here we are highly doping the n-type material. So we are calling it as n plus. And if it is named it as n minus, that is it's lightly doped material. That is here. This is n minus layer and it is lightly doped one. And if it is not mention anything, that is moderately doped. For example, if it is mentioned as P or N, it is lightly doped material. Okay. So first here layer is emitter N plus, that's of 19 power 10 power 19 per centimeter cube. So and this is your emitter. This is connected to emitter. And next we have base region. So this is base region. So it is of 10 power 16 centimeter per minus cube. And next comes the important region which will not be present in the small signal. That is drift region. So this is one of the important region which is in your power electronic devices. That is your drift region. It is used to control high current and high voltage because of that drift region. So its size is 10 power 14 centimeter cube minus cube. Okay. And next comes your collector. This base is connected to this region P. And next comes your N plus region. So this is your collector. This is connected to your collector region. So and next we have three modes of operations in the BJT. First one is cutoff region, active region, and saturation region. Okay. So the cutoff region, base junction is not forward bias, so there will no current flow through this, and it acts as an open switch. So normally when the base emitter junctions is reverse bias, that is it does current does not flow. So normally cutoff region it acts as a open switch. That is the name comes from that cut off region. So next comes the active region. So here the base emitter junction is forward bias and the collector base junction is reverse bias, and it is used to the current starts flowing in this type connection. And here normally in a BJT, the active region the BJT will be acting as an amplifier. So next comes the saturation region. Here both the junctions are forward bias, it acts as a closed switch. Okay. So let's see here, and we have a graph. This is your voltage current characteristics. We are plotting between voltage collector emitter and voltage and collector current. Okay. So this is your saturation region normally, and so this is your cutoff region, and this comes your active region, and this region your transistor acts as an amplifier, and here this is your saturation region. So next where we are using this type of power BJTs or converters, mainly in DC to DC converters. So, and inverters. power drives, power amplifier. These are the applications where we are using the power BJTs or any power electronic devices. So here next comes your switching characteristics. So the switching, we'll choose a device. Normally we'll choose a device. How it is switching, how efficiently it's switching, how what will be the time switching time, that and all we'll be noting down in order to have a before selecting a devices. Okay, so this is one switching characteristics of BJT. So first we have base emitter. So normally in a transistor, your input is your base. Okay. So here we have a base emitter voltage and base current. Okay. So how it is switching here is we have for switching we have the turn on time and turn off time. Okay. So how we are just making it. See here, this is your turn on. Okay, it takes some time to get turned on, and it takes some time to switch off also. That time, that is when a device comes from a non-conducting state to a non-conducting state, we'll be calling it as a reverse recovery time. Okay, so that's all with the power BJT. Thank you.